Okay, so let's summarise what we've covered in Lecture 6. First, regression models should be developed iteratively. Begin with an appropriate model specification, then assess whether the assumptions of the classic Miller model are satisfied. Secondly, what I hope I've demonstrated is that model specification can often be improved through simple transformations, interactive terms, and dummy variables. So you can think of these as ways of better representing the underlying relationships in the data and satisfying the modeling assumptions. And remember, transformations change the interpretation of the parameters. In log transform models, effects are proportional rather than absolute. Thirdly, we looked at the question of regression diagnostics. So we looked at outliers, leverage, Cook's distance, and variance inflation factors. And we said that these are ways of helping us identify influential observations and multicollinearity before we interpret the model results. So we're trying to diagnose and identify if there are problems. Fourth, we looked at violations of spherical error assumptions arising through heteroscedasticity and autocorrelation. These problems reduce the efficiency of OLS and, importantly, potentially invalidate our statistical inference, so they have to be taken seriously. We looked at two solutions. We looked at generalized least squares, weighted least squares. Well, that's weighted least squares being a form of generalized least squares. And we looked at robust standard errors. These provide practical approaches for estimation and inference when non-spherical errors are present. GLS transforms the model to restore the Gauss-Markov conditions. Robust inference leaves the estimates alone, but corrects the standard errors for the problems that they are subject to. Finally, throughout the lecture and in the tutorial, regression diagnostics and the appropriate remedial measures are demonstrated in R, and I encourage you to work through the tutorial material carefully, because these diagnostics are things you will use very frequently when you build a regression model in practice. So that's all for Lecture 6.